Greetings. So the Babylonians, the civilization between the rivers, whichever one it is, doesn't really matter, is a wonderful example of doing some advanced mathematics. And what I mean by that is we have tablets that have problems on them that are very unique and not just linear, such as we saw with the Egyptians earlier. The Babylonians will actually tackle solving quadratic equations. Quadratic equations typically of the form x squared plus some number times x is equal to another number. But that is a quadratic equation. It's just that the coefficient of the quadratic term needs to be 1. But we see this in one of their books. And permit me to read to you just for a moment. This is in Chapter 2, Section 5. And here's one of the problems that they have. I have added the area and 2/3 of the side of my square, and it is 35 parts out of 60. What is the side of my square? I have added my area. Now, for them, that's what they're talking about here. They have an area, so a square must have a side length. And I've added 2/3 of my side to my area, and it is equal to 35 parts out of 60. So for us, we would think about this today, writing this as x squared plus 2/3 x is equal to 35 over 60, and we might even simplify that. But I'm not. Now, what we see, though, in the tablets that talk about solving the quadratic equation is the following. And again, permit me to read to you. You take 1, the coefficient of x. 2/3 of 1 is, and they talk about the fact that it is written as 40 parts out of 60. Half of this is 20 out of 60. You multiply the 20, and its result is 6 parts out of 60 and 40 parts out of 3,600. And you add to the 35 parts out of 60. And the result is 41 parts out of 60 and 40 parts out of 3,600. Has 50 parts out of 60 as its square root. The 20 out of 60, which you have multiplied by itself, you subtract from the 50 out of 60, and 30 out of 60 is the side of the square. Now, that may not make a lot of sense to us because we don't do math today in an oral fashion or even in a written fashion. In the last couple of 100 years, mathematics went from being something where you would literally write down sentences to convey what you're doing, to now we simply want to look at the very abstraction of what we're doing and just deal with the abstraction. Some mathematicians say that when we took geometry out of math, we ripped the heart and soul out of mathematics, because now we deal with abstraction and we don't worry about really what it is we're doing anymore. This is a geometry problem. It can be represented in the world of geometry, but we never think of it anymore that way. And I'm not going to today, but I'm going to use this method for solving to look at what it is the Babylonians are up to with their solution method. So let us begin. So they're thinking to themselves when they say this, it said, you take 1, the coefficient of x. And that's not really what they would have said. 2/3 of 1 is 40 parts out of 60. So what they're focusing on is this piece right here. They're saying take the coefficient on x, which we know to be 2/3. Find half of this. Well, half of 2/3 is 1/3. Now, the way they write it, remember, has to be a fraction out of 60. So 3 times something gets me to 60. And if I'm not mistaken, that's 20. 20 parts out of 60. You multiply the 20 parts out of 60 and it results in a new number. And that number is 6 parts out of 60 and 40 parts out of 3,600. Now what they've done is they're saying multiply the 20 parts out of 60 unto itself. So they're saying 20 over 60 times 20 over 60. And they're going to get a number, and this number is going to be, if we write it out as a fraction, over 60 over 3,600, which I will remind you is 60 to the negative 2. It's where that's coming from. We're going to get an answer, and this answer is going to be 6 parts and 40 parts. So I get this result right here. And then they're going to tell me, you add to the 35 parts out of 60. Now, where's the 35 parts out of 60? Well, that's right here. So all of a sudden now I have 35 out of 60, and to that I'm going to add 6 out of 60 and 40 out of 3,600. And the result is 41 and 40. 41 parts out of 60 and 40 parts out of 3,600. Now, these problems from antiquity a lot of times are contrived, and here's the contrivance. Has as its square root. I can take the square root of this number, 41 out of 60 and 40 out of 3,600, and I will get 50 parts out of 60. Now, because I get 50 out of 60, and 30 is the side, and okay, well, you get the square root. The 20 which you multiplied by itself, or the 20 out of 60 multiplied by itself, you subtract from this. So I'm going to subtract from this result 50 out of 60. I'm going to subtract 20 out of 60, and that's going to result in 30 out of 60, which is 1/2. And that's the side of the square. And if we look at this, what we're claiming is I can put 1/2 into this equation and it should work. So before I go any further, I'm going to change colors so we can really see this in red. Let's plug in 1/2 into this and see what happens. So I'm going to take the left-hand side, and I'm going to have 1/2 squared plus 2/3 of 1/2. Well, 1/2 squared is 1/4 plus 2 over 6. The problem is I need a denominator of 60 because that's what I have on the right-hand side. So now, to get to 60s, I'm now going to play with this puppy. 4 will go into 60 15 times. 15 times 1 still results in 15. I need 10, and 10 on to 2 is going to give me 20. Now, when I add that together, I get 35 out of 60, and lo and behold, that is the right answer. Now, this is great for an example, but what in the world just happened? Well, let's take these steps for a minute and go to the next level of abstraction and simply think not of 2/3 and 35 out of 60, but these symbols and what they told me to do. So right here, if we think of this equation as x squared plus ax equals b, they said take 1/2 of a. That was the first thing we did, and we got an amount. That's the amount we're talking about. This 1/2 of a, what did we do to it? We're going to square this. That's what we did to get this amount. Now notice this amount we then added to a new amount. We're going to add it to b. So add the b onto it, and this is the line we're on. And it said we get this as an answer, but now if I take the square root of this number right here, I get a new number, And from this number, I want to subtract the original half of a. So I'm going to have square root of 1/2 of a group squared plus b, and I'm going to subtract 1/2 of a, and I'm claiming that this is the value of x, which we solve in the equation. Now, if you want to check this, what you need to do right now is stop the video, take this expression, and plug it back into x squared plus ax equals b, and see when you simplify the left-hand side, do you get the right-hand side? And if you don't pause the video, you're going to see it happen in just a minute, because I'm going to erase it and I'm going to verify this. And we're back. And we see I've got some clear space. So I'm going to take, and this is what we would refer to as verifying an identity. I'm going to start with the left-hand side and show that I can manipulate it to be the right-hand side. So the left-hand side starts out as x squared plus ax. And now I'm going to plug into that the value I think that works. So I'm going to have the square root of 1/2 of a as a group squared plus b minus 1/2 of a. And I'm going to square all of that plus a times the square root of 1/2 of a group squared plus b minus 1/2 of a. Now, what we want to do now is simply start trying to simplify things to make our lives better. So I'm going to have to square this, which means I'm going to get the square of the first, the square of the last, minus 2 times the product of the two. So if I square the first, I'm going to have 1/2 a as a group squared plus b. Then I'm going to have plus the square of the last, which is 1/2 a squared. Then I'm going to have minus, because there's a minus sign in here, 2 times the product of these two amounts, which is 1/2 a times the square root of 1/2 of a group squared plus b. So there's the first term multiplied out, and to that we're going to add this term in the back, and I am not going to bother multiplying that out yet. I often think of big complicated expressions as rattlesnakes, and I don't like kicking them unless I absolutely have to in mathematics. And you're going to see why I don't want to kick that rattlesnake. Now let's take a look. This -2 with this 1/2 is going to give me a -1. So it's going to give me a negative a times this square root. All right, notice I'm going to have a times that square root right here. So I know when I'm looking into this, I know all of this piece right here is going to take care of this piece when I multiply the a to it. And that's why I didn't want to mess with it. Now, I am still going to have to come back and deal with this a times the last piece. But let's come up here to the front now. 1/2 a squared would be 1/4 a squared plus b. I'm going to have a plus 1/4 a squared. And then now I'm going to have a minus 1/2 a squared. And you're probably thinking to yourself, what does this do? Well, 1/4 a squared, add 1/4 a squared makes 1/2 a squared, and if I subtract 1/2 a squared off, all the a squared stuff goes away, and the only thing I'm left with is a b, which is the right-hand side. Voila. We do have a method for solving quadratic equations. Not as general as the ones we solve in college algebra, but you just have to have a leading coefficient of 1. We know how to divide by a non-zero number, tickety-boo, we have a method. So the Babylonians actually had a very good sophisticated understanding of at least some second-order equations, and they were solving problems involving them. So as civilizations go, they're doing pretty doggone well mathematically. Scientifically, they're doing better than the Egyptians. And we're most probably going to get some of this knowledge will get transmitted to the West, in this case to the Phoenicians, which will then turn it over to the Greeks. So some of this knowledge is actually going to jumpstart Greek thought and knowledge. So as you study history, don't think of it as one group does something and it never bothers another group. Some of this stuff's interrelated, and you've got to figure out how they're interrelated. I hope this helps you see how they solve quadratic equations.